Hey guys, so we are back for week 8. We're going to still be talking about line of best fit, but now that we have already had a week of doing it, I'm going to do these notes a little bit differently. So we'll introduce the topic together, we'll set up our graph together, but then I want everybody at a certain point, we're all going to pause our videos. We're all going to pick our own 2 points. We're all going to do the work on our own, and then I want you guys to compare yours against mine so you can see all the different possibilities that there are for a line of best fit. Okay, so the first problem we're going to look at, only 2 problems we're doing today. Suppose you are studying the way a tadpole turns into a frog. You collect the following data to make a table that shows the ages and lengths of the tails of 8 tadpoles. So the first thing we're going to do is make a scatter plot. So we have the age on the x-axis, that's measured in days, and we have the length of the tail on the y-axis measured in millimeters. Okay, so the age, it looks like we can just count by ones. So I'm just going to do every other for space. Okay. And then for the length, I would say let's just count in ones for that as well. Okay. So now we can go ahead and plot all of our points. Okay, so once you are done plotting your points, I'm even going to pause the video and do the work on my own. I want you guys to go ahead and just answer B and C. Okay, we'll come back and we can do D together if you want, but all of our equations might be different, so your equations might be off, but I will come back and at least show you how I'm doing D. So B and C, I want you guys to pause your video, pick 2 points on your own, create your own line of best fit, and then figure out what your specific equation would be. Okay, so go ahead and pause right now and do that. So if you are playing the video again, that means that you went ahead and answered B and C on your own. So starting with B, describe the correlation of the data. It is negative, but when it says describe, it wants a little more than that. So I said as the tadpole ages, its tail gets smaller. That's what we're seeing. As it increases in age, the tail's length decreases. Now for my line of best fit, if you look at the line that I chose to draw, the points I ended up picking were 2, 15 and 10, 3. When I went ahead and found my slope for that, I got a slope of -3/2. I plugged it into my equation and I ended up with a y-intercept of 18. Okay, that was my line. Your line might have been different and that's fine. But as long as yours is around like -1.5x plus 18, that's all that matters. It does not have to be exactly the same. Now, when you look at D, it says use your equation to predict the length of the tail on a tadpole that is this many days old. So if you remember, days old is our x values, which means I'm going to put each of these values in for x to figure out what my y would be, what the length would be. So using your equation, not mine, y is equal to -3/2 times 1 plus 18. So -3/2 plus 18. So y is going to be equal to 16.5 and it's measured in millimeters. Okay. When it's 8 days old, you're going to put 8 in for x. So y is equal to -3/2 times 8 plus 18. So y is equal to, that's going to be 6 millimeters, because -3/2 times 8 is going to be -12. -12 plus 18 is 6. And then the last one, y is equal to -3/2. I'm going to put 15 in for x add 18. So negative 22.5 plus 18. So y would be equal to negative 4.5 millimeters. You can't have a negative length tail. So what it's saying is that eventually the tadpole is just going to lose its tail. Okay, this doesn't actually make sense, right? You can't have a tail that's negative in length. Okay, so you would just kind of say after a while, and if you even look at it, after a while, the length of the tail is going to go away because they're going to lose their tail because they're getting older. Okay, that's our first problem. Now we have a second problem. We're going to do it the same exact way. We'll set it up together, and then you're going to do B and C, but this time you're also going to do D on your own, and then we will compare. Going back up here really quickly, your answers in part D for this first problem might have been a little different from mine if your equation was different. As long as they were relatively the same, that's all that matters. So number 2, suppose you want to find out how long it takes to bike a certain number of miles. You collected the following data and made a table that shows the miles you biked and the time in minutes it took you to bike those miles. Okay, so we have miles and we have time in minutes. So miles comes first, which means that should be your x-axis, whatever is listed first. So miles is my x, time in minutes is my y. Okay, and looking at this, I can probably count by ones for miles. I'm still just going to skip writing every other. Okay, but then for time, the highest I need to get to is 107. So let me see, I'm going to probably count by fives for this. Okay, but I'm going to skip it, so I'm just going to write the tens on every other. Hopefully you can see that. So for some of those, we're going to have to do our best to just guess where they would be. It's fine if it's not perfect. Okay, so go ahead and plot all of your points as accurately as you can. So 5, 27, obviously you can't get exactly on 27, but you can guess it as close as possible. Okay, so go ahead and do that. Okay, so once you are done with your scatter plot, same thing, except you're going to finish parts B, C, and D. Go ahead, try those 3 parts on your own. I'm going to pause, you're going to pause, and then we'll come back together and review. Okay, so I didn't do D yet just because I wanted to stop for a second and talk to you guys. If you already did D, then just give me 1 second. Okay, so for B, obviously describing the correlation, it's positive. The more miles you bike, the longer it's going to take you to do that, so the time's going to go up. For my line of best fit, this is the line that I picked. I think this one, there definitely could be a lot of variation in the lines that people picked. The reason why I wanted you guys to see this really quickly, you can write it as mixed, as an improper fraction. You can write it as mixed numbers. I'm fine with a lot of these problems. I know I always said never write your slope as anything other than an improper fraction, but for more real life, real world scenarios like this, it's okay to kind of turn it into a decimal if it's going to be easier for you to use. Now in part D, it's probably going to be easier to use the fractions because you can type that into your calculator, but I still just wanted you to know that it's totally up to you. So give me 1 second and I will do part D. So for mine, guys, I ended up with roughly 164.8 minutes. That is what I got. Yours, obviously, if you didn't have the same equation as me, then your answer in part D is definitely going to be different. But just make sure that it's relatively along the same idea. Okay? So obviously, if you guys have any questions, we will be working together shortly in the guided practice. But other than that, I will see you guys soon.